Section 3.10 is about related rates. When we do a related rates problem, we take the derivative implicitly with respect to t. So I'm going to look at this equation and I'm going to take the derivative of both sides with respect to t. So here's my differential operator, d dt on a, and I'm going to perform d dt on pi r squared. d dt of a is just dA dt, and the derivative on pi r squared, first of all, we're going to use power rule, so we'll get 2 pi r to the first, and then we're going to multiply by the derivative of r with respect to t. So there's our derivative. Now we're being asked to find dA dt when r is 2 and dr dt is 3. In this example, that's pretty easy to do. So dA dt will be 2 times pi, r is 2, and dr dt is 3. So we get 12 pi. For the next equation, we're going to take the derivative with respect to t on both sides. We'll get dA dt. For the right side, we have a product rule. I will consider 2 pi r the first function and h the second function. So I'm going to do first times derivative of the second, which is 2 pi r times dH dt, plus second times derivative of the first. Second times the derivative of 2 pi r is 2 pi, and then we have to consider r a function of t, so chain rule means I have to multiply by dr dt. In this problem, we do have a value for r and we have a value for h. dA dt is 16 pi, dH dt is 2. We need to find dr dt. dA dt is 16 pi. 2 pi times 2 times 2 plus 4 times 2 pi times dr dt. So I'll get 16 pi equals 8 pi plus 8 pi dr dt, which is 8 pi equals 8 pi dr dt. Therefore, dr dt is 1. Number 3, I'm going to take the derivative with respect to t. So on the left, I will get 1/3 times dr dt. On the right, I will do quotient rule. So low times the derivative of high. The derivative of h minus 4 is 1 times dH dt minus high times derivative of low. High is h minus 4. The derivative of the bottom is just dH dt over the bottom squared. Okay, I'm trying to find dH dt. What I can do is simplify the expression a little bit. I'm just going to copy the left side. On the right side, I will factor out dH dt from both terms, so I'll get h minus 4 in the numerator, which is dH dt times h minus h will be 0, minus a negative 4 is positive 4, or h squared. Substituting in values we know, I know that dr dt is 1/2, so I have 1/3 times 1/2 equals 4 over 12 squared times dH dt. We'll do one more just to practice taking the derivative implicitly and then making substitutions. After this one, we'll actually work out a related rate word problem. A squared equals r squared plus h squared. So we get 2a dA dt equals 2r dr dt plus 2h dH dt. Substituting in, a is 10, so I have 2 times 10 times dA dt, which we are looking for. Okay, you might have noticed we have a variable here without a value, the h that's right here. So what I need to do is go back to the original equation, the a squared equals r squared plus h. So in a squared equals r squared plus h squared, I know that for our math problem, a is 10 and r is 8. So if I substitute in 10 for a, 8 for r, I can find out what h is. So this probably looks familiar to you. 10 squared equals 8 squared plus 6 squared. H is 6. So actually I could put a 6 in there. So my equation becomes 20 times dA dt equals 8 plus 4. That means dA dt is 3/5. A 14-foot ladder is leaning against a wall. Draw for yourself a diagram of a ladder against a wall, and we know it's 14 feet. That'll be important that we have a number that doesn't change. The top of the ladder slips down at a rate of 2 feet per second. So I'm going to label that as 2 feet per second. Just take note that that's going down. So that's going to be like a -2. I'm going to label the vertical side of this triangle as y, and I'll label the horizontal side of the triangle x. So the 2 feet per second that it's going down is a rate of change. So that means dy dt is -2. They're asking me how fast will the end be moving away from the wall. So that means the end of the ladder right here is moving away from the wall. So that's describing dx dt. So they want me to find dx dt. So after you identify what they want you to find, then next identify when they want you to find it. And when they want you to find it in this math problem is when the top is 6 feet above the ground. So that means when y equals 6. So that we're going to call that the snapshot. That's the snapshot moment that you're going to calculate for. We have obviously a right triangle here. So Pythagorean theorem is always one of the options for your equation. I'm going to set up Pythagorean theorem. The legs are x and y. So x squared plus y squared equals 14 squared. The hypotenuse is always 14 no matter what's happening to the ladder. Take the derivative implicitly with respect to t. So the derivative of x squared is 2x times dx dt, and the next is 2y times dy dt equals 0. We have 4 unknowns here. We have an x, a dx dt, a y, and a dy dt. Back in the given information, we do have dy dt given to us. We have to find dx dt, and we have a y given to us for the snapshot number. So what we need is a value for x. So we're going to go back to the original picture. The original picture has 14 on the hypotenuse. In the snapshot moment, y is 6. So then we need to find out what x is at that time, and we can use Pythagorean theorem for that snapshot to figure it out. So x squared plus 6 squared equals 14 squared. That means x squared equals 160. So x is 4 root 10. Now I have 3 numbers I can put in to 3 unknowns, and that'll help me find the 4th unknown. 2 times x is 2 times 4 root 10. dx dt is what we are looking for. Y is 6. dy dt is -2. Solve this for dx dt. Number 7. A man who is 6 feet tall is walking at a rate of 2 feet per second toward a street light that is 16 feet tall. So I'm going to draw a street light 16 feet tall. The man is walking toward it like this. The man is 6 feet tall. The question is about his shadow, and the shadow for the man is on the left here, to the left of the man, because the light source is up here. Now I'm going to call that length A, and the distance from the man to the light post, I'm going to call that B. So he's walking at a rate of 2 feet per second toward the light. So I'm going to label 2 feet per second down here, and that is headed toward the light pole, so he's getting closer to it. So his distance is shrinking to the light pole. So I'm going to dub that a -2 feet per second. At what rate is the size of his shadow changing? So they're asking me to find dA dt, because A stands for his shadow, and how fast the shadow's length is changing would be dA dt. This looks like a Pythagorean Theorem question because we have a right triangle here, but it's not because we don't have any information about the hypotenuse. Instead, this is one of those similar triangle questions. The man is here, he is also perpendicular to the ground, so we have similar triangles here. So I'm going to set up a ratio. A is to 6 as A plus B is to 16. So A is to 6 as A plus B is to 16. I'm going to cross multiply, so I get 16A equals 6A plus 6B. Then I can subtract 6A and divide by 2. So I have 5A equals 3B. Now I'm ready. I'm supposed to be finding dA dt, and I have an equation with A in it. So I'm going to take the derivative with respect to t of this equation. The derivative of 5a is 5 times dA dt equals 3 times dB dt. We only have two unknowns, and the one that we have a number for is -2 feet per second. This is dB dt because that's how fast he's moving towards the light. So this is 5 times dA dt equals 3 times -2. Solving for dA dt, I get -6/5 feet per second, or -1.2 feet per second. A boat whose deck is 10 feet below the level of a dock is being drawn in by means of a rope attached to a pulley on the dock. So let's set up a dock. And there's a boat out here. There's a pulley on the dock, and it's pulling in the boat. The deck of the boat is 10 feet below the dock. So that is going to be represented by this vertical distance right here. It's 10 feet below the dock. And the rope is being drawn in. So I'm going to label rope with an R. So being drawn in, that means the rope is changing length. And so it's going to be a dr dt to describe the change in the length of that rope. When the boat is 24 feet away and approaching the dock at a half foot per second, how fast is the rope being pulled in? So how fast is the rope being pulled in? That means I need to find dr dt. When do I have to find it? Well, when the boat is 24 feet away. So I'm going to use the letter x for the horizontal distance. So that's when x equals 24. That's our snapshot moment. We're going to have to find dr dt. The boat is approaching the dock at a half foot per second. That means the boat's headed this way. That's in the x direction. That's horizontal. So we were given dx dt as a 1/2. And it's approaching the dock, so it's getting closer. So that distance is closing in. So I'm going to dub that a -1/2. Now that I have a picture, I can see a triangle there. It's a right triangle, and I do have labels for all three sides. So I'm going to set up Pythagorean Theorem. X squared plus 10 squared equals r squared. And take the derivative with respect to time. So 2x dx dt plus 0 equals 2r dr dt. I have an x value of 24. I have a dx dt of -1/2. I just need an r value. So I'm going to go back to the right triangle, and I'm going to look at it in the snapshot. So in the snapshot, the hypotenuse, I don't know it, but there's a 10 on the left leg, and the bottom has a 24 in the snapshot. So this is actually a 5, 12, 13 right triangle. So that means R is 26 at the snapshot. So I can set this up now. 2 times 24 times -1/2 equals 2 times 26 times dr dt. Solving for dr dt, I get -6/13 feet per second. Number 9, a pebble is dropped into a still pool and sends out a circular ripple. So we're talking about a circle. We may not need the picture, but we'll draw a circle, and sends out a ripple. The radius, call it r, increases at a constant rate of 4 feet per second. So it's increasing, it'll be positive. And then they're asking how fast is the area enclosed by the ripple increasing. So that means they want us to find dA dt, A for area, when time equals 8 seconds. So we're talking about the area of a circle. So you need to know the formula for that on your own. A equals pi r squared. Take the derivative, dA dt equals 2 pi r times dr dt. We have three unknowns. We're trying to find dA dt. We have dr dt, that's 4 feet per second, but we need an r. So what we have to do is we have to think about how fast the radius is increasing, 4 feet per second, and it's doing that for 8 seconds. So after t equals 8, the radius will be at 32 feet. So I'm going to use that number for r. dA dt equals 2 pi times 32 times 4. So that's 256 pi feet squared per second, because this is area of the circle, so it's going to be a square unit. A spherical container is deflated such that its radius decreases at a constant rate of 10 centimeters per minute. So they're giving me dr dt is negative 10 centimeters per minute. At what rate must air be removed when the radius is 5 centimeters? So we have our when. What we're being asked to find when they're talking about air being removed is a change in the volume. So we're going to find dV dt when r equals 5. In this problem, they give us the volume formula. We can go ahead and take the derivative. dV dt equals 4 pi r squared times dr dt. dV dt equals 4 pi, the radius is 5 squared, and dr dt is negative 10. So I'm getting negative 1,000 pi centimeters cubed for volume per minute. Two automobiles start at point A. One is traveling west, the other north. So I'm going to set up westbound and a northbound arrow. That means there's a right angle in between them. The westbound one is traveling 80 miles per hour. The northbound is traveling 45 miles per hour. How fast is the distance between them increasing? So I actually need to think about the distance between them. I'm going to call that d, and they're asking us to find the change in that distance. So that'll be dd dt when time equals 3 hours. I do have labels on all three sides of the right triangle, so I'm going to use Pythagorean Theorem. I'll let the horizontal be represented with an x and the vertical represented with a y. So that's x squared plus y squared equals d squared. Taking the derivative, I get 2x dx dt plus 2y dy dt equals 2d dd dt. I need to find dd dt, so I'm going to get values for the rest of the unknowns. When t equals 3 hours, the westbound car has traveled 240 miles. So x would be 240 at the snapshot. So that gives me 2 times 240. dx dt is 80. The northbound car at 45 miles per hour, after 3 hours, we get 135 miles for the distance. So that's 2 times 135 times 45 equals 2. I need a value for d. So I'm going to go back to the triangle. The triangle right now has 135 on one leg at the snapshot, 240 on the other leg at the snapshot, and I need to know d. So you're going to set up Pythagorean Theorem. 135 squared plus 240 squared equals d squared. So using your calculator, you can find out that d squared is 75,825. And when you simplify the square root down, you get 15 root 337. So that is 2 times 15 root 337 dd dt. And when you solve for dt, I have the fraction, which is 1685 over the square root of 337. And the units on that are miles per hour. Sand pours into a conical pile whose height is always 1/2 its diameter. Conical pile means it's pouring down into a shape like this. Cone shape has a radius and it has a height. So they're telling me that the height is always 1/2 the diameter. Well, what's 1/2 the diameter? That's the radius. If the height increases at a constant rate of 4 feet per minute, so we're getting dh dt. The height is increasing, so that's a rate of 4 feet per minute. At what rate is sand pouring from the chute? So they want me to find volume. The sand represents the volume of the cone. It's going to fill up the shape of the cone. We want to find dv dt when h is 15, when the pile is 15 feet high. They gave us the formula for volume of a cone. There's 2 variables in there, so this is like a product rule. But wait a minute. We were told that h is the same as r. H equals r. So what I'm going to do is I'm going to substitute in h for r. So that'll be h squared times h, or volume equals 1/3 pi h cubed. So now when I take the derivative, I'll get dv dt equals pi h squared dh dt. That's much easier than doing product rule. And we did not get a rate of change for the radius. So we get dv dt equals pi times 15 squared. dh dt was 4, so we're getting 900 pi feet cubed per minute. Liquid is pouring through a cone-shaped filter at a rate of 3 cubic inches per minute. So they're giving us dv dt is 3 cubic inches per minute. Assume the height of the cone is 12 inches and the radius of the base of the cone is 3 inches. So this is 3. How rapidly is the depth of the liquid in the filter decreasing when the level is 6 inches deep? So this is finding, I'm going to call it height of the water, and h would be my letter. So I'm going to find dh dt when h is 6. The equation they give us is the volume of a cone. And again, the volume of the cone has an r and an h in it. So we would have to do the product rule. Well, we have information about dv dt. We have information about h. We know the length of r, but we don't have a dr dt to substitute in. So what I'm going to do is I'm going to find a relation between the h and the r. Okay, do you remember in a cone there's a height to the cone? Now there's also a height to the water that's supposedly in that filter. Now if I draw the h for the height of the water, here's h, then the water's down here making a cone shape inside of the cone. And the radius of that water, I don't know it, so I'm going to call it r. So I have similar triangles there. I'm going to draw that again larger. So right now the height of the cone is 12. I don't have the height of the water because it's changing. The cone itself has a radius of 3, but the radius of the water when it's inside the cone is unknown. So there are similar triangles here. From these right angles, I could see some right triangles, a big right triangle and a little right triangle. I'm going to set up the height of the water to the radius of the water equals the height of the cone to the radius of the cone. And when I cross multiply, I'll get 3h equals 12r, which means r is 1/4 of h. I'm going to take that r and replace it here in the volume formula. I have volume equals 1/3 pi, r is 1/4 h, and I'll have to square it, times h. So that cleans up to 1/4 squared is 1/16 times 1/3 is 1/48 pi h cubed. Now I just have the one variable. So when I go for finding dv dt, the derivative on the right is going to be 1/16 pi h squared times dh dt. There are 1, 2, 3 unknowns. I have dv dt. I have h in the snapshot, so I can get dh dt. 3 equals 1/16 pi times 6 squared times dh dt. So that means dh dt is 4/3 pi inches per minute.